Okay, in chapter 7, we are going to be taking another look at solving systems of equations and inequalities a whole bunch of different ways. Some of them are review and some of them are not. And so the first little section is mostly review, but I want to remind you what a system of equations is. What a system of equations is just basically when you have more than one equation and you have to have at least two variables in them. And you want to look for where those two equations or more than two equations intersect, where they all intersect. Um, and so you can do that algebraically, and we will learn some ways to do that or remind you of some ways to do that. And you can also do it graphically, which is what you can see in the right-hand picture, where you have graphed two things and you want to see where they intersect, and where they intersect is the solution. If you're going to solve it algebraically, then your solutions need to be plugged into every equation that's in the system, and it has to work in every single equation, not just one equation. Okay, so the first thing that we're going to do is we are going to solve this system right here, which happens to have two equations and it has two variables, an x and a y. So I need to find a point or more than one point or maybe no points where those two equations can be solved. And I can look at that algebraically and I can look at that graphically, which we will do. Um, First of all, what I want you to get in the habit of is thinking about these two equations and what kind of graph they would make. So in your beginning of your chapter 7 notes, the first couple of pages are a reminder of the 12 basic functions that we talked about in Pre-Calc A. Um, and so you want to look at whether things are linear or whether they're being squared or cubed or um, whatever. But you want to just be able to kind of look at an equation and recognize what kind of equation it would generate a graph of. Okay, so the first, both of these happen to be lines. We can get them into y equals mx plus b form. So this does happen to be a linear equation, and this one also happens to be a linear equation. And so I want you to think about what is the minimum and maximum number of solutions you can have with these two particular equations, two lines. So I want you to think about that. I want you to hit pause and see what you can come up with. Okay? Hopefully you have figured out this. They might have no solution if they're parallel. They might have one solution if they intersect in one point, or two lines might have, if this is my coordinate grid, they might have infinite solutions if they end up being the exact same line that is on top of each other, then they would cross in infinitely many places. Okay? All right, now that I know that, we are going to just quickly remind you how to solve a system using substitution. With the substitution method, if you recall, that's where you want one equation solved for either x or y, and then you plug that into the opposite equation so that you only have one variable left, and then you simplify. So I'll repeat that again. You want to get one of the equations solved for either x or y. In this case, it's easiest to get this top equation right here solved for y. You can move the y to the right side so that it's positive, and then move the 10 to the left side and make it negative. So the y is going over, the 10 is coming this way, and this equation will turn into positive y equals 2x minus 10. Okay? That is still the top equation. Notice I have not touched the bottom one at all, so that's where I'm at. Okay? Now I want to remind you that you will circle this. Notice it says y equals. So wherever I see a y, I can replace it with 2x minus 10, which is what I'm going to do in this opposite equation down here. So I'm going to replace that y with 2x minus 10, and that second equation will now look like this. Whoops. Okay. And now I'm going to simplify that and just simply solve it. So I have 6x. When I distribute that 4 through, I have 8x minus 40. Okay, and I can simplify that to 14x. Add the 40 to the other side equals 41. Unfortunately, this does not come out to be a very pretty number, but it does come out to be 41/14, and I'm going to leave it just like that. You are not done. If you remember at the very beginning, these two equations have two variables in them, an x and a y. And you need a solution for both of them. So I've got the x, and now I just need to get the y. So here's the x. What I'm going to do with it is I'm going to go all the way back up to where I circled. And you can plug it into any equation, it doesn't matter. But I'm going to take what I circled and replace the x with what I now know to be as 41/14. So y will become 2 times 41/14 minus 10. And then what I would suggest doing is just don't be freaked out by the fractions. Just put these into your calculator, hit math enter so that you can deal with the fractions. And I know you can do this, not a problem. And what will happen is y should come out to be negative 29/7 when I do this, okay? When you give your solution to systems of equations, we typically give that in an ordered pair, and we list the x first and the y second. So our solution in this case should probably be listed as 41/4, comma, negative 29/7. This is the x, this is the y, and that's sort of proper etiquette for listing solutions to a system of equations. Okay, so that should be a quick reminder. Here's another one. This one is just a little bit trickier. We do want to solve this algebraically. I'm also going to have you stick it onto your graphing calculator so you can kind of picture what's happening on this particular one. But before we do that, I do want you to picture what kinds of equations these are. Okay, this, as you can see, has a cube in it. So this is a cubic equation. If you look at your 12 basic functions sheets that I gave you, you can see that a cubic equation typically has a shape that looks something like this. It might be more curvy or less curvy. It might go up and down the opposite directions, but it does look something like this. The bottom equation, y equals 3x, is a line, okay? It's not squared, it's not anything. So this is some sort of a line. It's not horizontal or vertical because it does have an x in it, and I can see that it has positive slope, so it probably looks something like this. Okay, so now I want you to think about how many solutions could you have if you have two systems that look something like this, a cubic and a linear. So I want you to hit pause, and I want you to think about that. Okay, hopefully you can come up with these scenarios. It could be that this is your cubic, and your line might go through, let's say, like that. If it goes through like that, you have 1, 2, 3 solutions. Okay? It could be that this is your cubic, and this is your line, and then you only have 1, 2 solutions. Or it might be that this is your cubic, and this is your line, and you only have 1 solution right here. Okay, so hopefully you've pictured all the things that could happen. Those are it. And we are going to take some time to solve this now. Okay, we are first of all going to do this algebraically. Again, it's easiest if you do this probably by substitution. Both of these equations already happen to be solved for y. So I just need to replace one with the other. So I am going to take this one, and I'm going to circle it, and I'm going to replace it in the other equation where it says y, because it says y equals. So when I do that, what happens is I have x cubed minus 6x equals 3x. Okay? Of course, what you want to do next then is get everything onto one side of the equation so that you can simplify this. So I am going to subtract 3x and I will have x cubed minus 9x equals 0. Okay? At this point, what you want to do is you want to try to factor what you can. Okay? Some people want to think the only way that you can factor is to undo the FOIL and to have two parentheses like this, and that's not the case. Remember, the first rule to factoring is to always think about what it has in common and what you can pull out. So in this case, x cubed minus 9x, they both have an x in them. When I factor out an x, then what I have left is x squared minus 9. Okay? And I am not done because this x squared minus 9 that's in here happens to be a perfect square. And if you remember what that is, it's something squared minus something squared. So that actually factors as x minus 3 and x plus 3. Okay, now once you've got it completely factored, which I do, I'm going to set each part equal to 0. So I will say x equals 0, and then I will say x minus 3 equals 0, and then I will say x plus 3 equals 0. And of course, when you solve those then, obviously, you get x equals 0. Okay, here I get x equals 3, and here I get x equals negative 3. The problem is these are only your x solutions. So now what you need to do is you need to go and you need to plug those back into one of the equations to figure out what y goes with it. Okay, so I'm just going to take all of those and I am going to plug them in to this equation right here. Okay, so one of my solutions was x equals 0. If x is 0 and I plug 0 in right here, then obviously 3 times 0 means that y is 0 also. Okay, the other one was x equals 3. If I plug 3 in right here, 3 times 3 gives me a y value of 9. And obviously the other one was negative 3. And if I plug that in, I get a y value of negative 9. Okay, so it's looking like the three solutions to this system are 0, 0, 3, 9, and negative 3, negative 9. Okay, so now what I want you to do is I want you to check this on your calculators. So we are going to put this into our calculator, these two equations, and we're going to check this. Okay, well, when you do this, when you put equations into your calculator, remember that you need them solved for y. Okay, so we're going to go up to y. I'm going to clear out what I already have in here. My first equation was x cubed minus 6x. So here's my x value. I'm going to cube it. And then I have minus 6x. Okay. Then, oops, look at that. I forgot to take the exponent off of there. So you know what? I'm going to clear this out and we're going to try again. X cubed minus 6x. Okay. There we go. And their other equation was y equals 3x. All right, I'm going to graph this. I'm not sure if my window is set right, but it looks like it is. If it's not, hit zoom and 9, or zoom 6, sorry. Zoom 6 puts you in the standard window, zoom 6. All right, so if you remember, we had one solution of negative 3, negative 9, which is confirmed right here. We have another solution of 0, 0, which is confirmed right here. And we have another solution of 3, 9, which is confirmed right there. So I can see both algebraically and graphically, I am getting the same answer, which is great news. Okay. All right, now I'm going to remind you how to solve with elimination. Okay. When you do this with elimination, your goal is to get one of the variables to drop out when you add and subtract the equations together. So if I were to add these two equations right now, which by the way, both are lines, okay, I can get both of them into y equals mx plus b form. Okay, so I can see that they're both lines. If I add these two equations together right now, I would get 7x and negative y and 55. Okay, sorry, 45, not 55. And that is not dropping one of the variables out. So I'm going to get one of them to drop out. I am going to choose to get my y's to drop out in this case. Right now, if I add 2 and negative 3, I don't get 0. So you want to multiply, in this case, both equations by something so that you get one of the variables to drop out. I am going to multiply the top equation by 3. When I multiply the top equation by 3, this becomes 9x and 6y and 36. Okay? If the top equation is 6y and I'm trying to get my y's to drop out, the bottom equation has to be negative 6y. So that means I need to multiply the bottom equation by 2 so that when I distribute that 2 through, I'm going to get negative 6y. When I distribute the 2 through, I have 8x minus 6y equals 66. Now what I want to do is I want to add those two equations together. And when I add 9x and 8x here, I get 17x. When I add 6y and negative 6y, those drop. And when I add 36 and 66, I get 102. Okay, and then of course I can divide by 17. And I get an x value of 6. Please make sure that you don't stop there. Remember, there's two variables in the system, an x and a y, so you need a solution for both variables, okay? Once you have that, you can go ahead and take that x and you can put it into any of the equations that you want. I'll just go ahead and put it into the top one. When I put an x value of 6 in then, I have 3 times 6 plus 2y equals 12, or 18 plus 2y equals 12, or 2y is negative 6, and so y is negative 3. Okay, so my right and final answer would be 6, negative 3, x comma y. Okay. I do want to point out to you that sometimes you get no solution, like we talked about. If you have lines and they happen to be parallel lines, then you have no solution. Okay, so if I look at this particular example and I try to solve it with elimination, and I kind of just worked this out because I don't want to necessarily take the time to run all the way through it. But if I multiply this equation by 2, it turns out to be 6x plus 4y equals 10. Then when I go ahead and add those drop out. Those drop out. So I have 0 plus 0, which is 0. And then if I add this, I get 20. So 0 doesn't equal 20. All my variables are gone. 0 does not equal 20. It's not a true statement. And so my answer has to be no solution. So my question is, what does that mean about the graph? Well, if there's no solution, that means there's no place that the lines intersect. And so if there's no place that the lines intersect, then they have to be parallel lines. Okay? So that's what that means. Okay? In this case, we're kind of doing the same thing. If I work on solving it by elimination, I multiply the top equation by negative 3. Okay, that got me here. If I add the two together, I get 0 equals 0. Obviously, my variables are gone, so that's a weird case. I have no x's and y's left, but I do get 0 equals 0. That is a true statement, which means I have infinite solutions. The only way you get infinite solutions if you have two graphs that touch each other in every single spot there is. So they basically are the same line. All right. Okay, and then we're going to do one more strictly on our graphing calculator so that you can get some more practice with that. What we have here is, first of all, on the top equation, we have both x and y being squared. It's not linear if the y is squared. Both my x and my y are squared, and I don't know if you remember that, but what this is then is into this circle. Okay, so I have a circle here. Here I have just an x and a y. Neither one of them are squared. So this I know is going to be a line. Okay, I can tell that right now. I want to do this on my graphing calculators, so I just kind of want to show you what happens here, okay? In order to have these go onto your graphing calculators, you need to get both of the equations solved for y, okay? I'll start down here with this easy one, easier, I should say. One, if I start down there and I want to get that equation solved for y, I'm going to need to subtract x to the other side so that I have negative 2y equals negative x plus 2. And then, of course, I will divide by negative 2. And when I divide by negative 2, I'll have y equals 1/2 x minus 1. Whoops, I forgot my x. Okay, so this is one equation that I need to put into my calculator. If I look at the other equation, this one right here, I need to get it solved for y. So the first thing I will do is I will subtract that x squared to the other side. Okay, and so then I have y squared equals 4 minus x squared, or you could have negative x squared plus 4, that's fine either way. Okay, that's what y squared is. My calculator needs it to say y, so what I need to do is I need to take the square root of both sides. And don't forget that when you take the square root of both sides, you need to have a plus or minus in front of it. So what I really get here is positive or negative 4 minus x squared. Okay, here's my equations that I'm working with. Now, the problem is that your calculator can't do the positive and negative at the same time. So we actually need to enter these in as two separate equations. You'll enter one in as you see it, and you'll enter the other one in with a negative in front, so that you get the positive and the negative all in one thing. If you only do the positive, it will only get the top half, and we know that it's a circle, okay? So let's go back to our calculators here. And I'm going to go up to my y equals, and I'm going to clear out what I have. Okay, I will put the line in first, and my line, if you remember, was 1/2 x minus 1. Okay, then I'm just going to show you this. If you forget the plus and the minus, this is what's going to happen. I'll have the square root of 4 minus x squared. Okay, I'm just going to go ahead and hit graph right here. Notice I know I'm supposed to have a circle. It does not look like a circle, by the way, because this is a rectangular window that we're viewing it in, not a square window. And so it does distort it a little bit. But notice it only gives me the top half of the circle, which is really kind of a bummer. Okay. Then let's, in order to get the bottom half, remember, we need to put that negative square root in there. All right, so now I've got the negative in there. I'll go ahead and hit graph again. And now my calculator gave me the bottom half of the circle. Okay, so it looks to me like I have two intersection points. This one might happen at a perfect corner. Okay, it sure looks like it anyways. That this one looks like it's happening at a corner. It looks like it's the point 2, 0. Okay, I'm going to just check that out using my table. And then this looks like it is not a very pretty number, but I can see that that's an intersection also, okay? So first of all, I'm going to go to my table and see if 2, 0 happens to be on any one of those equations, okay? So if I go to my table, I do second graph, okay? And what you can see, yeah, right here on this row. Okay, notice the point 2, 0 is on all three of those graphs. So it is where the circle and the line intersect, which is at 2, 0. So that's one solution. Okay, I'm going to go back to my graph. Now what I want to do is I want to see where I can find the other part. Okay, so this is what I'm going to do. I'm looking for this solution right here. Okay, I can see that it's where the black line and the blue line intersect. Okay, so what I'm going to do is I'm going to use my calculator to help me. I'm going to go to the calculator function, which is second trace. I'm looking for an intersection point, so I'm going to choose number 5. Okay, notice down here that my calculator is asking me for the first curve. Just look at where your cursor is flashing on. Since it's where the blue and the black line intersect, you want your cursor on either the blue or the black line. It doesn't matter which one. You just don't want it on the red one because it's not intersecting the red. Okay, so I can move my cursor back and forth from one line to the other by using the up and down arrows. Okay, mine's on the blue line. I'm just going to hit enter. Now it's asking me for the second curve. So that's the second line, second of the 2 lines that are intersecting. Mine are the blue and the black. I've already got it on the blue. So it is intersecting on the blue and the black. So the next time I want to make sure I have my cursor on the black line, then hit enter. Then it's going to ask me for a guess down at the bottom. Now I want to use my left and right arrows, and I want to scroll my cursor to about where that intersection point is and hit enter one more time. And it tells me that my intersection is at -1.2 and -1.6. So here's my other solution to this problem. These 2 points are my solutions. Okay, so that should do it for today's lesson.